This is A-level mathematics with Mr. Hire. For a while, we have been studying differential equations using various methods. We have solved questions on separation variables and homogeneous equation. So today we want to solve question on linear equations. Now, how do you know if a particular question can be solved using a linear equation? Now, before I solve this particular question, whenever you have any question in this form, dy dx plus maybe ky is equal to f of x. Whenever you can express any differential equation in this form, okay, then this is what we call a linear differential equation. K is the coefficient of y. There must be a y here, a y variable here, okay, and k is the coefficient of that y. Then there must be a function of x at the right hand side. Okay, now, so how do we solve it? There are steps you need to follow before you solve it. The first step is you start with the coefficient of y. Okay, when you have a linear differential equation like this, the first step you do is that you find the coefficient of the y variable. In this case, is 1 over x, so you can call it capital F is equal to 1 over x. We call it factor. That's our factor. So the factor is the coefficient of the y variable. Now, that's the first step. The next step is you find what we call the integrating factor. Integrating factor. That is I dot f, and it has a formula. The integrating factor is exponent of the integral of your factor, which is the coefficient of y, factor dx. So the integrating factor is exponent raised to power integral f dx. So the integrating factor here is going to give me exponent raised to power integration of 1 over x dx. Of course, you know that when you integrate 1 over x, it's going to give you log x to base e, which we also call ln x. So my integrating factor here is going to give me exponent raised to power log this x to base e. Anytime you integrate 1 over x, you have log to base e. Now, I know in mathematics, when you do exponent raised to power log exponent, this exponent will cancel this log to base e. So you have your integrating factor to be x. So after you have gotten your integrating factor. The next step is that you now multiply, you go back to the original question. You will now multiply each term by that integrating factor. So you multiply each term by the integrating factor. So we are going to have x dy dx plus 1 over x times x, that will give me just only y, is equal to x squared times x, that will give me x cubic. Now, after this, the next step is you will, this particular one, you will bring out, you will deduce something, like a product rule that will give you this one back. Okay, you will deduce d of dx of y times integrating factor. Okay, so you have d of dx into y times, what is the integrating factor? That is x. Y times x is equal to x cubic. We only use this formula when you get here, d of dx of y times integrating factor. So I have d of dx of yx is equal to x cubic. Of course, when you find d of dx of yx, you are going to get back x dy dx plus y. Because if this is yx means y times x, so if I differentiate yx here with respect to x, I'm going to get back x dy dx plus y. So from this stage, the next thing is to now separate the x variable from the y variable. So from here, I'm going to separate the x variable from the y variable. Now the first thing I'm going to do is d of yx is equal to x cubic dx. Okay, so d of yx is equal to x cubic dx using cross multiplication. Now, the next step, you will now integrate both sides. Integrate both sides. That will give me integration of d of yx is equal to integration of x cubic dx. Of course, in mathematics, when you have integration and d, they will cancel each other because integration is the opposite or the reverse of differentiation. So this cancel this. So I have yx is equal to, now if I integrate x cubic with respect to x, I'm going to have x root of power 4 over 4. Okay, then I will now add my constant plus c. So if I divide both sides by x, I'm going to have y is equal to x cubic over 4 plus c over x. So this is the final answer of the solution of this differential equation. So this is a question on linear equation. In the next series, we are going to solve more examples on linear equations for us to understand it better. So please don't forget to subscribe to this channel in order to understand how to solve differential equation. See you for my next series. Bye bye.